Imagine the universe before the first light, before stars, before anything ever shone. Time itself had only just begun to flow, as space stretched and matter struggled to exist. The early universe was a boiling ocean of energy, chaos, and raw creation. In that chaos, something extraordinary might have been born: the first primordial black holes. These ancient black holes existed long before any star had a chance to shine. Unlike stellar black holes, they were not born from dying stars, but from the universe itself. Imagine a universe so dense that even the smallest fluctuation could crush light itself. Physicists believe that tiny differences in density caused regions to collapse under their own gravity. From these invisible wells, the first seeds of darkness were planted across the newborn cosmos. Some primordial black holes could be smaller than a grain of sand, yet heavier than mountains. Others might have weighed as much as 1,000,000 suns, formed just seconds after the Big Bang.
These objects didn't destroy the universe. They may have shaped it.
They could have become the anchors for galaxies, the first knots in the fabric of the cosmos. Think of them as the invisible threads weaving the grand design of the universe.
Without them, the structure of galaxies might never have taken shape. Each primordial black hole may have acted as a gravitational magnet, pulling the first atoms together.
Even now, they might still be out there, silent, ancient, waiting to be found.
When we gaze into the oldest light captured by James Webb, we may be seeing their fingerprints. Perhaps, in that eternal darkness, lies the memory of the universe's very first heartbeat. Imagine pointing the most powerful telescope ever built toward the edge of the universe's dawn. Instead of bright stars, it finds tiny red specks scattered across the endless darkness. These are the little red dots, ancient galaxies born when the universe was still an infant. 700 million years after the Big Bang. A blink of an eye in cosmic time. The James Webb Space Telescope doesn't see invisible light, but in the deep warmth of the infrared. Infrared light can travel through the fog of time, reaching us from the universe's first moments. Webb's mission was simple yet monumental: to find the first stars, the first galaxies, the first light. But soon, it saw something that no one expected: galaxies that shouldn't exist yet.
Among them, one object stood out: a galaxy called Abell 2744.
This tiny, ancient galaxy burns far brighter than any others around it.
When Caucasian female scientists studied its light, they found something massive hidden at its center.
A black hole, 50 million times the mass of our sun, at the heart of this young galaxy. But that makes no sense. How could such a giant form so early, when the universe was still young?
Normally, it takes billions of years for black holes to grow this large.
Yet QS01 appeared almost fully formed, a cosmic riddle written in red light.
Could it be one of the first black holes ever created? A Titan? A primordial black hole?
If true, this would be our first glimpse into a forgotten chapter of cosmic history. Sometimes, science doesn't start with a grand discovery, but with a single mysterious dot of light. And perhaps, hidden within those tiny red sparks,
lies the story of how everything truly began.
Imagine looking deep into a galaxy, born when the universe was just a few 100 million years old. It's small, fragile, barely formed flame, yet something enormous is hiding at its very heart. Astronomers call it a Bell 2744 QSO1, a name as strange as the object itself.
At its core lies a black hole, 50 million times the mass of our Sun. That number alone breaks everything we thought we knew about cosmic evolution.
The universe back then was still learning to make its first stars.
So how could a monster like this exist before stars even had time to live and die?
It's like finding a grandfather older than his own children, a paradox written in light.
Normally, black holes form from collapsing stars, feeding slowly on gas and dust for eons.
But QSO1 seems different. It's far too young to hold such an ancient giant. Stranger still, this black hole appears completely alone. No stars, no dust, no glowing halo. Even the elements that make stars, iron, carbon, oxygen, are almost absent here. That means no generations of stars had yet lived and died to create those metals. So how could such a massive black hole exist in a place where nothing else has formed? If confirmed, this discovery could rewrite how we understand the birth of the cosmos.
Perhaps black holes didn't come after the stars, Elisha. Perhaps they came first.
Some scientists believe QSO1 may be a primordial black hole, born just seconds after the Big Bang.
If true, it could be one of the universe's very first seeds, the postulate, the foundation of galaxies to come.
Think about that, Owen. A black hole older than the first star, shaping everything that came after.
Without stars, without dust. Sometimes, the first thing born in the universe isn't light, but shadow.
And perhaps from that shadow came every star, every planet known, and eventually, us.
Science is often imagined as a moment of joy, a thrill, a triumphant eureka echoing through a lab.
But in truth, discovery rarely begins with celebration. It often starts with doubt.
When the James Webb telescope observed the distant galaxy Abell 2744 QSO1, something didn't make sense.
Revealed a massive black hole, 50 million times heavier than our sun Braspus, inside a galaxy too young to hold it.
The universe then was still learning to make its first stars. Nothing this enormous should exist yet.
Instead of cheering, the scientists grew uneasy. Could this be a mistake?
They checked every pixel, every reading, every beam of light from that distant source.
Maybe the telescope malfunctioned. Maybe the signal came from somewhere else entirely.
For months, they recalibrated, tested, verified something, until the truth became undeniable.
The data was solid. No errors, no interference, no illusion.
And in that silence, one question hung in the air. If it's not an ordinary black hole, by every law of physics we know, such an object shouldn't exist so soon after the Big Bang.
Could it be something else, Dreyek? Something older, more ancient than stars themselves? That question led scientists back to an idea from half a century ago: primordial black holes.
In the first seconds after the Big Bang, space was so dense it could have created black holes directly.
If that's true, then the black hole in QSO1 might be one of the first children of the universe.
Imagine play, a remnant from a time when light itself was still learning how to exist.
Discovery often begins not with certainty, but with a whisper of doubt that refuses to fade.
Some ideas in science sound too wild to believe.
In 1971, a young physicist named Stephen Hawking dared to imagine something extraordinary.
Alongside his colleague Bernard Carr, he asked a radical question about the very first seconds of time.
What if, right after the Big Bang, the universe created black holes, before stars or galaxies even existed?
These would be the first black holes, born not from dying stars, but from the chaos of creation itself.
Hawking called them primordial black holes, ancient remnants from the dawn of existence.
Normally, black holes form when massive stars collapse under their own gravity.
But in those first few seconds after the Big Bang, there were no stars, only energy, chaos, and gravity.
Imagine a vast cosmic ocean, where tiny ripples in density suddenly collapse into invisible wells.
Some of these black holes could be as small as grains of sand, yet heavier than mountains.
Others might be millions of times heavier than the sun, formed in a single heartbeat of cosmic time.
For decades, no one could prove Hawking's theory. The instruments simply weren't powerful enough.
Then, 50 years later, the James Webb Space Telescope spotted something impossible.
It may be exactly what Hawking once imagined, Apohan, a primordial black hole from the universe's first breath.
If so, these ancient black holes could have been the seeds from which galaxies were born.
Think about it, Ab. Every star, every planet, even our own Milky Way, may have started this way.
Before there was light, there was darkness. And from that darkness, creation began.
Perhaps Hawking was never wrong. We just needed time to catch up with his imagination.
Sometimes, the first thing the universe ever created was shadow.
Most black holes are born when stars die, collapsing under their own gravity in a final blaze of light.
But some black holes didn't come from dying stars at all.
They were born from the universe itself, from its first heartbeat.
Imagine the universe just seconds old. No stars, no galaxies, only chaos and heat.
In that chaos, tiny regions slightly denser than the rest began to collapse.
These were the first black holes and primordial black holes, born.
They didn't need stars to die. The universe itself was enough to create them. Some were smaller than grains of sand, yet heavier than mountains.
Others were giants, millions of times heavier than the sun, formed in just a blink of cosmic time.
To imagine one, picture a marble in your hand that weighs as much as the Rocky Mountains.
Most of the smallest primordial black holes have already vanished.
Slowly evaporated through a mysterious process called Hawking radiation. But the larger ones, the ancient giants, may still be drifting out there today.
Hidden among galaxies, older than any star. waiting to be found.
Think about that, Mike. A black hole that's older than light itself.
These ancient relics might be the seeds of galaxies, Trounsu, the first anchors of creation. Perhaps our own Milky Way began around one of them.
If so, then before light existed, darkness was already shaping the universe.
Imagine a telescope so powerful it can look back to the dawn of time itself.
That telescope is the James Webb Space Telescope, humanity's window into the early universe. Unlike any before it, Webb doesn't just look far, it looks back in time.
When it stares into deep space, it captures light that began its journey over 13 billion years ago.
Because in the universe, light is memory, Omni. Every beam, a message from the past.
Unlike Hubble, which sees visible light, Webb peers into the invisible glow of infrared.
Infrared light reveals what optical telescopes cannot. It sees through cosmic fog. Think of it as a pair of thermal eyes, watching the faint warmth of creation itself. Its 6.5-meter mirror collects the oldest light in existence. Webble's design is a masterpiece. 18 hexagonal mirrors aligned with atomic precision.
When it opened its eyes for the first time, humanity saw the universe as it was billions of years ago.
Those faint red dots you've seen in Webb's images, they're the first galaxies ever formed. Astronomers call them the little red dots.
And hidden among them lies a mysterious object.
Webb captured its light from a time when the universe was only a few 100 million years old.
When that light left Abell 2744 QS01, neither the Sun, Earth, nor the Milky Way yet existed.
Those photons traveled across time and space 13 billion years apart to reach us today.
Through Webb, we're not just observing galaxies, we're witnessing the birth of structure itself.
It's showing us how light, gravity, and time began their eternal dance. And somewhere in that distant glow, a colossal black hole was already waiting.
James Webb doesn't just show us where we came from, it shows us when.
If Hubble revealed the beauty of the cosmos, that Webb reveals its childhood.
It reminds us that every ray of light we see tonight is an echo of our own cosmic beginning.
Imagine the universe as a vast web, woven from threads of light and gravity.
Every galaxy you see is a node in that web, part of the grand structure of the cosmos. But have you ever wondered who or what wove that cosmic web in the first place?
Some scientists believe the first weavers were not stars, but black holes.
Not the kind born from dying suns, Dwood, but ancient ones, born with the universe itself.
These are primordial black holes, relics from the very first seconds after the Big Bang. Think of them as gravitational anchors for Bath, invisible seeds around which matter began to gather. Each acted like a silent magnet, pulling gas and dust together across billions of light years.
Over time, these clusters of matter became stars, galaxies, and entire cosmic networks.
If that's true, then black holes may have shaped the universe long before the first light appeared.
In a strange way, darkness gave birth to light.
Astronomers call this the cosmic scaffolding, the hidden framework of creation. These black holes may have been the architects of galaxies, guiding where light could take form.
Even now, the Webb telescope sees the faint fingerprints of this ancient architecture.
Somewhere, hidden in that distant glow.
If that's true, then everything, every star, planet, and an East Asian male person, was shaped by invisible gravity.
The universe itself was sculpted from darkness, long before light ever existed.
The stars you see may have been born from shadows.
In astrophysics, the more we learn about the universe, the more we realize how little we truly understand. Take dark matter, for example, Trispling. It shapes galaxies, yet remains completely invisible.
We can't see it, touch it, or detect it directly, but with
For decades, scientists have hunted for this missing ingredient of the cosmos.
Then came a daring idea. What if dark matter wasn't exotic particles at all, but black holes?
Specifically, primordial black holes meteorits, ancient relics born in the universe's first heartbeat. They're invisible, dense, and everywhere, clean, the perfect candidates for dark matter.
It sounded almost too elegant to be false. But science demands proof.
After decades of study, calculations revealed a sobering truth. PBHs make up only a few percent. Not enough to explain dark matter, but enough to change everything about how galaxies formed.
Imagine the early universe as a river of chaos, flowing, turbulent, formless. Now drop a few stones into that river.
Those stones were primordial black holes, anchoring the first structures in the cosmos. Around them, gas and matter began to gather, forming the first stars and galaxies.
They were the universe's first architects. Silent, invisible, but essential. Without them, the universe might have taken hundreds of millions more years to organize itself.
PBHs may not be dark matter, but they could be the reason stars exist at all.
In a way, darkness gave birth to light. Chaos taught the universe how to shine. So next time you look at the stars, remember, what you see may owe its life to what you cannot.
In science, not every discovery is an answer. Sometimes it's the right question.
That question today comes from a distant red speck in the cosmos, Abell 2744 QSO1.
Seen by the James Webb telescope, this tiny galaxy may host one of the first black holes ever born.
A black hole so massive, so early, it shouldn't exist entirely, and yet, there it is.
If it's real, it could be the first primordial black hole ever observed by humanity.
But for now, it's still just a preprint, not yet peer-reviewed or fully confirmed.
In science, a discovery isn't truth until it survives scrutiny.
Think of it as a first draft, promising, exciting, but waiting for proof. That's the beauty of science. Patience and doubt
go hand in hand with wonder. To find the truth, we'll need new eyes, and they're already on the way.
In Chile, engineers are building the ELT, the Extremely Large Telescope. When finished, it will be the largest eye on Earth, able to dissect starlight itself.
ELT will tell us what this strange galaxy is truly made of, Leo. Its metals, its age, its story.
And beyond Earth, another eye is coming, the ESA's New Athena telescope.
Together, these instruments may confirm whether QSO1 is truly a primordial black hole.
Or perhaps it will reveal something we haven't even imagined yet. Science is not about certainty, it's about patience with the unknown.
Maybe Hawking's idea will finally be proved. Or maybe the universe still keeps its secret.
Until then, we wait, listening to the oldest light in the universe.
Perhaps, just like the cosmos itself, this journey is beginning again.
Concepts once forgotten can rise again, awakened by a single spark of discovery. That's what's happening right now.
Nearly half a century ago, Stephen Hawking and Bernard Carr proposed a daring idea. In the universe's first seconds, tiny ripples in density could have collapsed into black holes.
Not born from dying stars' crane, but from the collapse of space-time itself.
These were the primordial black holes, the universe's first shadows.
But without evidence, the theory faded, buried beneath decades of silence. Until now.
A faint red glow, a galaxy named Abell 274441.
At its heart lies a black hole so massive, so ancient, it shouldn't exist.
Unless it isn't a normal black hole at all.
If proven true, it could be the first direct evidence that Hawking was right.
That the universe was born not only with light, but with absolute darkness. In the beginning, light and darkness weren't enemies. They were partners in creation.
Light gave us stars and galaxies. Darkness gave them structure and gravity.
If QSO1 is confirmed,
a half-century-old question again. New telescopes like ELT and New Athena will soon search for the answer. Maybe they'll confirm it. Maybe they'll uncover something even stranger.
Either way, science moves forward by returning to the questions we once left behind.
We often think of black holes as destroyers, cosmic voids that devour everything in their path.
But what if the universe's first black holes didn't destroy? They created.
Imagine the universe in its first heartbeat. No stars, no galaxies, only chaos and light.
And within that chaos, small, dense pockets began to collapse under their own gravity.
That's where the first black holes were born, evil, the universe's original architects.
It sounds paradoxical, doesn't it? That the first act of creation began with darkness. But in physics, as in life, creation often begins in collapse.
Those early black holes didn't end creation. They seeded it.
They pulled matter close, gathering energy, and laid the foundation for galaxies to form.
Without them, there might be no stars, no galaxies, perhaps no us.
Maybe darkness isn't the enemy of light. It's the canvas upon which light is painted. Think about it. Without night, could we ever truly understand dawn? Without silence, would music even exist?
Even in the universe, balance is everything. Light and dark, chaos and order, life and loss. Maybe those black holes were never destroyers, but silent builders, patient and invisible.
From collapse came stability. From emptiness came form. From darkness came light.
The universe, it seems, was never at war with itself. It was learning to create.
And perhaps that's the lesson hidden in every black hole.
Endings are just beginnings, waiting to shine.
The universe was born not only of light plague, but of perfect, necessary darkness.